All right.
Where'd the red one go?
Well, that's
Yep, I think I sent you the link.
yep, you did.
All right. Like I said, nobody comes, we'll just make some weird, crazy shit.
How many? I don't give a shit.
Just 5:30. I'm popping out. Well, probably going through like 5:20.
It'll just be me and you, Sean. Or you can go home either one.
Well, no, I mean, I'll be back. I'll be back.
I'm not doing anything.
It's 20 minutes.
What?
My one is literally at most 20 minutes.
Oh yeah, I gotta go do that too later.
What time is that? Have you signed up for it?
I didn't set a time for it.
Then you're too late.
I didn't set a time I had to set a specific period.
Yeah, you're supposed to set up a specific period of time. It was a sign up thing.
Oh well, too bad.
Yeah.
Let's see.
Okay, workshop's live.
All right.
Yeah, you missed your opportunity.
Oh, it's all good.
I'm taking one of these.
What? Oh, you gonna take one? Yeah, go ahead. You gonna work on something?
Oh no, I was going to follow along.
Oh,
That's
okay.
why I'm
Awesome.
here. I look at this and I'm like, that just does not look fun.
It's crazy. Yeah, that's definitely gonna be better to use those.
Yeah.
All right. So let's get going. All right. So today what we're gonna work on is basically recreating this. This is basically kind of like a small little what should I say? Kind of like a security alarm. And welcome to all of those that are possibly watching. I can clearly see that there's like one of you. So hello, whoever that person is. It is literally him. That's so sad. But basically, all this is kind of like a small alarm that's based upon the movement or detection. So that's what this is like ultrasonic sensor here for. Right now it's goofing because I have the distance a little bit too far and it's actually interacting with the wall that's over here. So I got to set that up and I will connect it to my laptop. Basically, what we're going to do is kind of go over kind of what it means for these microcontrollers, general overall setup, how to go through the process of setting up your environment on Windows, as well as go ahead and knowing how to actually install the software, get everything going, and basic overview of what these different components do, how they work, and how exactly we can use these things in conjunction and together to make this cool little device. So I'm gonna be right back. I'm gonna be on my computer, and I'll also share the screen as well whenever I modify it. On the other piece. And I'll just do this from the ground up with a completely new kit. Okay. So within our kit, and as we'll hopefully do in the future, maybe allow people to be able to, come to the go into the CS lab, ask one of the ACM officers or possibly even one of the TAs to allow them to actually check out or use one of the microcontrollers here in the CSX lab. So that way you guys can actually have access to these microcontrollers there and kind of work with things and play with them while you're here on campus. So as you all know, most of you guys have all heard of our Arduino. Basically, what the Arduino is a microcontroller, which is effectively a very smaller version, less complex as a computer. It has other appropriate components that allows it to do very basic calculations and basic operations. That allows it to communicate through digital and analog inputs and outputs, as well as be able to effectively interface with a computer system or PC, right? For ours, we're using the eLego Uno. We actually have some other types of microcontrollers as well. The Metro from Adafruit. This one's actually better. It's a little bit more powerful, and you'll definitely see a lot more speed with it. So definitely, whenever you guys do get a chance to come by, if you want to stop by and get some microcontrollers and work with them, definitely pick out one of these Metros. They have basically the same overall interface. So you can basically do the same thing with both the Metro version of the platform as well as the version for the Uno R3. What's up, Jax? So you can go ahead and sit down anywhere you want to. All right. So let's go ahead and look at and start working on this. So inside of our kit, what we're going to be using is an LCD display. We're going to be using a ultrasonic sensor. We're going to be using a IR controller. We're going to use the, see here, the potentiometer. So you can look very closely here. This is what a potentiometer is. I'll explain these things a little bit closer, but you'll notice here it's kind of like this sort of half semicircle here. And you're probably going to find a small knob as well within the kit. And you just place it like this and you'll get your cute little potentiometer. Potentiometer, LCD, IR receiver. And we actually need the actual IR receiver, which is going to look sort of like this. This here. That's our IR receiver. Oh, you can get any of those kits. Just go ahead and pick one out. And so let's see here. As well as that, we actually have ourselves the breakout board. And basically, this is a prototyping board, and it's really, really useful whenever you don't want to possibly mess up or damage your microcontroller, whenever you want things that are more, what should I say, physical. So like you can actually solder to this thing and have it where if you actually had a device you wanted to reuse, but then you still wanted to move your Arduino to other projects, you could always just basically attach this thing to it. And that's what we're going to use. It provides kind of easier connection to the ground and 5-volt sections of the microcontroller. So it's a lot easier. So breakout board. We're going to go ahead and take out the battery and the appropriate jack. And lastly, all we need now is our buzzer and the actual breadboard. There's a breadboard. This is probably one of the most useful things that you could possibly find, at least in this process. It kind of allows you to effectively connect to specific ports indirectly. As you'll see, and what's really important here is that there's actually conductivity that works down each column relative to this direction. So basically on the other end or other edge or side of this sort of port section here in this middle section, basically every single plug here that's in the same column, those are all connected to each other conductivity wise. So that allows you to basically have it where you can have a connection here and then have multiple different possible other wires routing off of that same connection, which becomes really, really useful whenever you have more complex things, which you're going to see here, which just looks crazy. As for these blue and red section here, that's basically dedicated in such a way for your ground and for your actual 5-volt power, whatever voltage power that you're going to be supplying. And those are conductive laterally instead. So all of these are connected down through the ground. All these are connected down to the power, and the same thing on the opposite side. So be very careful when you're doing this that you don't allow your ground and your power wires to kind of like interact in that way, because you'll basically create a little short circuit, which is a no-go. So you don't want that. But we'll go a little bit more into that and more detail of that. Well, let's go a little bit more into detail about these separate components after I get this buzzer. Where are you, buzzer?
Is this the active or the passive buzzer?
Get the active buzzer.
All right.
And whenever you handle one of the kits here, you'll see there's actually a cute little thing on here that provides all the images of everything. So definitely when you come by, if you want to check out that, it'll have the proper nomenclature on it. So Here we go. All right. And the thing that'll show different about the active buzzer, it's got a big old plus sign on the top. You'll see this section here. That's our active buzzer. All right, so we've got all of our parts together. So let's go ahead and talk a little bit more about what exactly they all do, how do they connect, and why are they useful, how are they flexible, etc. So in this case for our breadboard, as I just explained here, this is really for parts of our prototyping. These are mainly just focused on doing prototypes. And like I said, this actually can just lay it right on top of the Arduino. I already talked about our actual Arduino itself. So the LCD display, basically this uses a relatively complex set of bit operations to be able to control a 16 column by 2 row LCD display. Basically, we'll go into a little bit more detail, but all of these specific ports here are digital connections that basically use bit operations, basic 0 1s to correlate that into different text and different shapes as well, because you can add custom shapes on these LCDs. So it's really, really cool to set this up, and this will provide us our main means of communicating and viewing any print statements, any types of things that we need to know about actual code that's running in the background. So we'll definitely be using that. And you can go ahead and put that onto the breadboard. Preferentially, you kind of want to put it sort of not too much in the center, but probably off to the side a little bit because you need enough room. And make sure it's at the farthest away from the side that more than likely is going to be your what do you call it? Arduino is going to be located. And don't hurt your fingers while you're doing this. This can sometimes be annoying because not all these prongs are properly. There we go. All right. I'll see that too. Got in there? Awesome. So now that we actually have the proper LCD display on here, we're now going to go ahead and talk about our ultrasonic sensor. So the ultrasonic sensor, it uses, well, as it already states, ultrasonic systems to basically project a ultrasonic sound, and then it records that sound after it's been bounced off. And it does it at a very specific frequency range so that it has its sensor, or I guess it's set up to an extent, be able to detect that specific range. So what we're going to do here is you'll notice there's actually a trigger, and there's an echo, and there's a ground, and there's a VCC section on there. And you can see that very small little text that says that. And basically what that means is that the trigger port is actually the port that represents triggering off the ultrasonic pulse, and then the echo port is actually the thing that actually takes in or records that response. The VCC and the ground, that's actually just the basic power, right? That does that. And basically by you turning on and off the trigger, you're able to basically make pings or requests for the sensor to actually send out and make a request for the distance. And another interesting thing about that is that inside of our actual system, it actually causes it to yield, and you'll see that in the code a little bit, is that the farther away things are, the longer it actually takes for the ultrasonic sensor to give a response. So you definitely got to keep that in mind whenever you're writing your code for this. I found that out the hard way. So you can go ahead and set up and place your ultrasonic sensor, preferably the farthest ports to the right, or just anywhere on there, wherever direction you want to point it. Make sure that the ports or the connections are, once again, in this sort of column direction to ensure that that is set up. You all got that? Awesome. Now that you've got the ports, you got that all set up. Now let's talk about our IR receiver. So our IR receiver, it's a relatively similar process and concept in terms of where you have a ground, you have a power, and then you have one port here in the center. If I remember, it's the center. I have to double check. It actually acts as the thing that actually receives data as well as projects data, because this is also our IR receiver and a IR sender. So basically, by using that singular port, it's able to basically take in IR data, and it has its own sort of small um, um, sort of section that actually converts that into a bit representation that's relative to the type of controller. In this case, we're using a simple NEC controller, and it actually has it such that the data that is sent is actually in a format that correlates to this type of controller. So if it was a Sony controller, it would have a completely different ending, a starting file representation. So it's really, really cool. And this is super useful. Probably what we're actually going to do later is we're actually going to make it where a couple of microcontrollers are actually going to talk to each other and communicate back and forth through the IR process, which could be after this cool project. We're gonna kind of do this for fun since nobody really has, and we're gonna have a little bit of Zoom goes on. So, all right. So let's set up our receiver. Preferentially, again, try to put it on the farthest edge. We want to make sure our stuff is kind of spaced appropriately. Try to get it as deep as you can in the port here, because sometimes if it doesn't have a very good connection, as Alexander said, we might make two microcontrollers tell your mama jokes to each other or something stupid like that. So that's going to be setting up our receiver. This is super cool. This is the controller that we're actually going to use. For your controllers, when you first get it out, it may have it where the battery is there. Let me see if I can find this controller very quickly. We got so many of these things that it's kind of like a giant mess over here. Where's the other controller at? This kid had a controller. Let's see here. Oh, I'm stupid. All right. So, go ahead and take out the battery for that. And that'll be for this is actually just send out the ping for the IR receiver. Okay. So now that we've got that, we now have to just go over our basic buzzer. So there's a difference between an active buzzer and a passive buzzer. The big difference is that an active buzzer has an internal mechanism that actually does the vibration by actually converting the current into like an actual vibration that makes the sound. A passive buzzer doesn't actually have that, and it requires sort of like it actually requires you to use pulse width modulation, which is basically this process of changing the output or the amount of voltage at a certain frequency to actually cause it to make noise. So you'll notice that when we implement this active buzzer, it's really just the way to change the frequency is just to changing how long it's on and off to change the sort of sound or noise that it makes, which is pretty cool and interesting. So you can place this. You can basically place this anywhere. It can be anywhere. Just I usually put mine like sort of between the ultrasonic sensor and the LCD display. Okay. And then last but not least is our potentiometer. So our potentiometer, what this does is this effectively changes, if I'm correct, this changes the resistance along the circuit. And basically what that does is it kind of changes the amount of voltage that is provided to the system. In this case, this is how we're going to control the brightness of our LCD display. And what we have to do here is make sure that you have it such that the ports that are facing, or these two prongs here are going to be the things that actually do our, what should I say? They are the things that actually control or pass act as our ground and as our voltage and our ground, or not voltage and ground, our power and our ground. And so what we're going to do here is actually just kind of put it on this sort of place here, kind of near the LCD display, because we're going to want to change that for our LCD display. Try not to break it when you're putting it in there because it's kind of weird, at least on this board. And kind of place it where it's kind of facing this way, like I said, where the ground ports and these ports are facing towards where our Arduino is going to theoretically be. Okay, so now we have all of our components basically set up and ready for us to begin. So wiring. This is going to get nasty, y'all. So basically, what's the easiest way to do things, at least from my opinion, is to first set up your ground and your power connections, and then set up your actual connections for the digital outputs or analog outputs last. So what we're going to do is I'm going to go ahead and try to go over a little bit of how the setup is. So I wish I could give you guys a nice diagram, but it's I didn't have enough time to make it. So so we're going to have to do it sadly the old-fashioned way. So first, what you want to do is go ahead and put your prototype board on your microcontroller. And like I said, you can use either one. You can use either the Metro or the other one. They all have basically the same thing. Once you set that up, you can go ahead and then set up our very base connections. So what I said earlier about how there's this sort of laterally the positive and negatives, they actually are connected. All of those are connected. We're going to go ahead and connect our ground and our 5-volt to those connections on the farthest ports. So let me just go ahead and get out these wires. Our boy Sean donated some really, really good wires. You'll probably want to use those. They are appropriately rigid. Can I have some of those real quick?
You don't have any of them?
No. Wait. Oh, yes, I do. So the big difference between the ones that we have here and the other ones is that these are rigid, and it makes it significantly easier to place things and to make sure that wires aren't googly gop. This is a very, very clean. It makes it where your setup is very nice and easy to understand. For right now, we're just going to go ahead and just use the normal wires. But if you do have these with you, definitely use these more. I'm just going to use these just because they're available to me, and I'm just going to do it that way. All right, so let's go ahead and set up our 5-volt connection. And we're going to place that on the positive end, that red section here. I wish I had like a little thing I could zoom in on. And basically, we're going to take that 5-volt connection here. Then we're going to do our ground connection. And actually, it'd probably be better for us to use sort of a longer cord for this process. But we'll just see what we can do, how to look. And we're going to connect our ground right here. So our convention is going to be black is ground, red is to our power, right? Or to our primary current source. So, all right. So now we've got that. Let's start trying to actually connect our sensors and components. So first and foremost, we have ourselves. We're going to have ourselves a connection to our IR receiver, and I'll just use a smaller cord for this. Our receiver, we're going to make sure that first middle port is going to be connected to, once again, so we have red, we're definitely going to be putting it in our red section here, right? We're going to connect that middle port to red. Then the port, and like I said, this is very important for the directionality, and you can actually check the small writing that's in the front of the IR receiver. It has the word G, R, and Y. G is going to be ground, and then R is red. Usually that's what I'm saying for the context. And then Y is going to be our actual connection that we're going to use to connect to our sensor or to our actual ports over here, which we'll do later. So, like I said, depending on your orientation, make sure you check to see that the black one is going to the ground. All right. So now we have our grounds set up for this. And we'll add in our actual connections and sensor connections a little bit later. All right, so now let's set up our ground and power for our potentiometer. So for our potentiometer, it technically kind of doesn't necessarily matter the directionality to an extent for some of them. For this one, at least the implementation that we have here, or the type we have here, we're going to use directionality does matter. So we got to make sure we have it in the correct section. From there, so we have the one that's on the far, well, I guess from y'all's perspective, I guess that'd be the left, but if you're looking at it from this perspective, right. Yeah. It's going to be right there. And I'm goofing up my little cords here. See, this is what I'm talking about. It's like sewing. You're going to put the other one over here to the right. And I'll leave this this section here, and I'll create the proper diagram of it later on for you guys to look at. Okay. So have these two connections here. And then we're going to make a very special connection, which we're going to represent with our yellow wire. So yellow wires, we're going to usually have that represent either, usually we want to use that for things that are going to be modulating or changes in voltage. So technically, in a way, this connection here is actually modulating the voltage or detecting modulations in the voltage in this case. So for this yellow cord, it's going to go into V0. And like I said, all of these things are properly labeled onto these sections of your microcontroller, not microcontroller, on the LCD display. So you'll see on the LCD display, there's something that says V0, and that's what we're going to connect to our potentiometer. And basically all that does is V0 acts as kind of like our, like I said, as the thing that changes the voltage, the backlighting on our LCD display. Technically, you don't necessarily need a potentiometer for it, but for the safety, or should I say the longevity of the LCD, it's better to have a potentiometer. So that way you can kind of change the brightness depending on, how dark or how light things are. Okay. All right, let's add in our ground and our power wires for the LCD display. So for the LCD display, starting from the VSS, so VSS is going to be our ground. That's going to be the one that's on the far left of it if you were looking at it from the LCD display. Looking down. That's going to be our ground. One of our grounds, actually. There's actually multiple grounds. Then the one immediately next to it, which is going to be VDD, is going to be power. So we're going to use a red cord to represent that. Okay. And then from there, we're then going to skip these next two because those are going to be kind of like, once again, those are going to be our connections that we're going to use for our sensors and other ports that we're going to use on the digital ports on the micro Arduino. And while I'm actually talking about that, I forgot to tell you guys about what the difference is between digital and analog. So on the microcontroller, there's these digital ports here and the analog ports on the opposite side. The digital ports are basically focused and are created in such a way that they only literally output highs and lows, which is effectively either it puts out the full maximum 5 voltage or it puts out 0.8 volts, which represents a low voltage. And to that actually tells the system whether or not it's on or off. And that's what it means by digital, just zeros and ones, on and off state. Analog is kind of like a range of values. Usually that range is usually between like 0 and 255 under most circumstances. I think that the Arduino might have it between 0 and 126 between on different representations, but if you want to include positive and negatives, but that's a whole different thing. And basically by using those different types of connections, we can change what types of information that we want to receive and what types of information we want to send. Most of your sensors, most of your digital inputs, sensors, LCD screens, all of that are usually going to be using the digital, since the chips that are in them usually represent those things or do the calculations using bits. So that's kind of like how it is. But technically, you could use a lot of analogs. The analogs are used kind of for things like stepper motors or for other things that require very fine-tuned control. But you can technically do the same thing with digital, but that requires something called pulse width modulation that basically will kind of simulate analog control by changing how much power is almost being put out over time. We'll go over that one day, maybe, I don't know. But that's a little bit more complicated. All right, let's get back to actually wiring stuff. So let's find A and K, which is on the far right side. Those are going to be your last two. A is going to be your power, red, and then K is going to be your ground. Okay. All right. So now we have all of our power cords and everything set up for our LCD display. Now let's go ahead and set it up for our buzzer. Ooh. So our buzzer is a little bit less complicated when you think about it. Since the buzzer, all it really needs is power. So for right now, all we're really going to set up is the ground, because the power is actually going to be the connection to our microcontroller itself. So all we really need to do here is set up one ground cord, and you can use either side. It actually doesn't matter which side you use, left or right, whatever you want to do, whatever floats your boat. You know what I'm saying? Man, I am just. Oof. Y'all need to just stop me. I wish if anybody here's recording this, if you see me, just slap the shit out of me. All right, and last but not least, let's work on the ultrasonic sensor. And just to let you know, the reason why I'm not talking to people behind me, because they already know what they're doing, kind of. They've already made one of these before. They're cool kids. All right, so you'll notice on the ultrasonic sensor, the VCC port, which is the one that's on the farthest to the. Just look for VCC port on here, because the directionality is just terrible. This is the beauty of someone actually naming these things. Look for the VCC port. That's going to be, once again, our voltage control port. And then on the very far other end is our ground. And it should be 4 away from each other. Yes. I think I just put this in goofy. Here it is. Yeah. And then connect that to the proper ground. So now we have, and I'll just put this a little bit over here. We now have all of our appropriate ports for the ground and the power. Now that we have that, now we're going to go ahead and set up our actual connections for the sensors, as well as for the LCD display and everything else. So once again, let's start back over here. We're going to go back to our relay. And if you can, I'd find a white or yellow cord. Whichever one's the longest, because you're going to need to connect over. All right. And actually, we'll just go from 0 to 1 actually first. So our LCD display, the first port that we are going to be connecting to is going to be D3. No. Actually, no. It's going to be the RS port, my bad. So the RS port, which is going to be to the right or left, whatever direction you want to look at, is going to connect into the digital port 1 of the microcontroller. We're going to use green to represent that. Then to the immediate right of it is RW. And RW is then going to be connected to, actually, did I miss see that? Oh, yeah. Actually, RW is actually going to be a ground port. I forgot about that. So you actually need to add one more ground wire between these two. Because now you should see basically there should be a black cord between the green and the orange cord. And that orange cord is then going to go into port 2 of the digital port. So really the orange cord should be in port E of the LCD. Then we're going to connect the rest of the ports with blue cords. And these ports are basically there to actually they actually send the data that represents more complex shapes, or rather in this case text, since all we're doing is really showing text. If we could use all of these ports technically, but that's how we would send far more complex shapes and far more complex things. Like if you wanted to have like heart shapes and stuff like that show up, you'd have to use more ports. So you're going to connect D3, which should be here. D3, or actually D4. Into digital port 3 on the microcontroller. Then you're going to connect D5 to port 4 on the microcontroller. You're probably already getting the gist of this already. D6. How y'all doing back there?
You sunk my battleship.
Huh?
I said you sunk my battleship.
Battleship. See, I can hear you. I can hear you can hear battleship in this. Then D6 into port 5, and then D7 into digital port 6. So right now you should already have 6 ports connected into the digital ports and 6 ports connected into the actual Arduino board. So yeah. So now that LCD display is now effectively connected. Now let's go ahead and connect our ultrasonic sensor. Oh. So we can use just a simple green cord for this. So our ultrasonic sensor is going to be connected into our port 7. So it's usually easier. You can just start from port 7 on the digital port on the microcontroller. And we're going to try to connect it back over here to the echo port of our ultrasonic sensor. And then we're going to connect the actual trigger port to port 8. Yes. Things are going to kind of start getting a little bit tight. As Bubba Sparks once says, get it right, get it tight. All right. So we got the ultrasonic sensor. So now let's connect ourselves to the IR receiver. Might want to get one of the longer white cords. So that last port that I talked about earlier, that yellow port, the Y port of the IR receiver, that then connects to port number 9 on the microcontroller. Okay. And then our last but not least, our last connection is going to be from our port of our buzzer, active buzzer, to port 10. Which we'll just connect right here. Okay. All right, so now we have all of our appropriate connections in our system. All right. So now let's kind of deal. So how y'all feeling over there? How y'all doing?
I got a special one.
Oh no.
Also, I'm like 99% certain I missed like all of the LCD.
Okay. All right. I'll bring you over this one then. You can just check this one out. So this one's already built up. All right. All right. So probably now you're probably thinking, all right, we got all this stuff together now. How the heck do we make it work? So best way to do that is to actually, we're going to code it. Get some, and the Arduino's primary language of coding is C++. Some people may shout in terror of hearing the word, the great God that is C++, but I think it's one of the most sexy things in existence. So C++ kind of is, you guys are more mainly possibly coders on here. You know that C++ is well known for its trust in programmers, trust in the coder. That has its positives and its negatives. And its syntax and overall structure is actually very flexible in such a way that allows you to do some really cool stuff. And it is incredibly lightweight and incredibly fast, which becomes really important for something like a microcontroller, which doesn't have that much processing power to begin with. So for this, we're going to set up our environment, and I'm going to have to transfer computers because this is my work computer right now. I'm doing this on. So give me a short second. Yeah. Do 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 do. Do, 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 do. Do. Yeah, we ain't got no. Wait, play some what? Japanese music. Jeopardy music. Oh, I thought you said Japanese. I was like, why is he talking about Japanese music? What are we talking about? Let me get my charger, y'all.
You any help button off?
Nah, except for my dude. I'm just going to turn on OBS and switch the controls. Because guess, even though my computer is relatively nice, it actually does not have controller. I mean, a camera. So, yeah.
Oh, yours doesn't have a camera?
Nope, this does not have a camera. It has everything else. It's got a pretty nice graphics card in it. I can play most games on it. Do most CAD software, heavy calculations. Got the newest processor in it. It just doesn't have a camera.
No camera.
Just no camera. I like it that way. I don't like nobody seeing me.
Yeah, that's fair. I usually have mine, the little slider to block the camera.
Mm-hmm.
We have that on.
And as y'all can tell, if you're ever gonna look at these videos or anything, I'm kind of free forming it. This is just how it is. Next year they're gonna do great. They're gonna be like, oh, they're gonna have the best people. They're gonna be way better than my stupid ass and me doing stupid stuff. So go to those. Those will be great. All right, let me set up this. And I'll actually post later the actual code because you're not gonna want to recode this. This is nasty. It's pretty nasty. But we'll kind of go into a little bit of what we need and how to set up the Arduino space, specifically how to set up libraries and use those libraries and set up our code and kind of get this thing running. That's our goal today. Because then we're going to have some cute stuff. Super cute. How's it coming along, bro?
There's one fit.
Doesn't want to fit?
There's one fit.
You just gotta let it stay up higher a little bit. Sometimes that board is weird, especially the breakout board. I mean prototype board.
No, wait, am I the only one dude?
Yeah, you're the only one. No, that's fine. But at the end of the day, all that matters to me is that we were able to teach something to somebody. Y'all better learn something, or else at least my one goal is wrong. So
Well,
to
be
learn
fair, I
fucking
learned
something.
This, to be fair, I learned this in high school. So.
Man, that ain't enough. I'm gonna teach you some fancy stuff. Because if we get this done sooner, probably what I will do is we'll work on some really more interesting projects just for the fun of it. Probably, like I said, some communication between different microcontrollers, stuff like that between our sensors. All right, so let me start my stream. Go here to settings. All right. So we're going to just very quickly switch stream sources. Is that even possible? Do y'all know if that's possible? Can you switch your stream source midstream?
I don't stream.
I'm not sure.
I'm actually wondering that right now because I didn't think about it. I forgot that I had to actually show you guys the code. Actually, I don't technically have to show you guys the code. I could just literally just download it on here because y'all were probably gonna have to do that anyway. So, but
You can post like a link or something.
that's true. We could just start working on the cool stuff. I want to work on some cool stuff because the code. So I'm just going to download the code. We're going to see it run. We're going to make sure everything's good. I'm going to show you some basic debugging, physical debugging, because at the end of the day, this controller workshop was more focused on the controller workshop of things rather than the actual coding of things. So I will post the code though, because right now, like I said, we're just chilling. All right, let's see here. Do. All right, let's see what we got here.
I think so. Great. Good.
Okay. Interesting. Interesting. Stream key.
It is.
Apply. Okay. And then let's start the stream back up.
This is. That's cool.
It's looking good.
Yeah, this looks very clean.
Oh, dang, that does look clean. Man, how'd you do that?
What's
Man, can you please show the class what you have done?
with
No.
this kit?
Man, you made it look clean.
Yeah, come on. Show.
Come on, show it. Show the class how much cleaner his is. Let's do a side by side right here. It's gonna be real sad. This is the reason why I said those other wires. Actually, he used the regular wires. He's just trying to flex on them.
No, he did use his wires as well.
Oh my gosh, look
That's
how
what
clean
makes
that
it
is,
so
you guys. Looks how clean that is. That's how a good system's supposed to look right there. That's sexy. That right there makes me wet. All right, this is good. So basically, we're gonna go ahead and set up. We're gonna get this connected. We're gonna upload the code. We're gonna make sure that his works. So let's go ahead and get his working. Wait, how do I change? Is it possible to do like multi-streaming? More than one ingestion is using the primary URL. Open widget.
You do like a
Oh.
part 1 and a part 2.
So maybe I can just pause that.
You could call it part 1 and then part 2.
Part 1 and part 2. I'm fine with that. I could just do that, right? Part 1 and part 2. I'm fine with that. I could just do that right here.